Welcome everybody to my talk at Percona Live Online. I'm going to talk today about PostgreSQL-As-A-Service, comparison of cloud providers. My name is Banck. I work at Credativ. We're a Germany and US based vendor-neutral open source support and consulting company, and I work in the database team there. We have a PostgreSQL competence center, but we also support a lot of other open source products. Right, so what I'm going to talk today, I want to compare the functionality of the main cloud providers, and I want to talk about a couple of specific points here because I only have 30 minutes, so I do not want to cover everything. I just want to cover a couple of specific points that we came across in our consulting with clients over the last year or so. And that's the community involvement of all the major players and the up-to-dateness of their major and minor versions and the out-of-memory behavior. These are the ones. So there's also a very good general talk by Christoph Pettis from last year's FASTA MPG Day called Hosted Environments for PostgreSQL and an Objective Look. And you can see the slides in the URL there. I'm not sure there's a recording, but the slides are pretty extensive and you should also check that out. Right, so what are we going to look at? We're going to look at the three big cloud providers, and they all have a PostgreSQL offering, and it's called Microsoft Azure Database for PostgreSQL, or Azure in short. It's Google Cloud SQL for PostgreSQL, or GCP, or Amazon RDS for PostgreSQL, RDS. So I'm not going to talk about Amazon Aurora. I'm not going to talk about Microsoft Citus Hyperscale. Those are very different products. Those three here are basically vanilla Postgres with a couple of small patches to make it better integrate with the cloud offerings. Now, those are, I guess, arguably the big three, both in the cloud service itself, but also for PostgreSQL as a service. There's a couple of other niche players. Crunchy Data, for example, has a Crunchy Bridge offering, but it's very different. And some others have some database as a service offerings there. There's a general Gartner Magic Quadrant of cloud database management services things, and there's also those three are the leaders. I guess Alibaba Cloud has a pretty okay offering for PostgreSQL as well, but all the other ones, SAP, IBM, I think they have Postgres on their cloud, but it's pretty much a niche player as far as PostgreSQL is concerned. So I'm only looking at those three. That's also the ones that I actually know somewhat we have clients working with them. Right, so first up would be functionality. And first off, I want to talk a bit about the common functionality that all three of them have. So all of them provide SQL access or database connection access to the database. They do not provide shell access. Also, they do not provide Superuser-access. So that would both give you access to the operating system, which is something that the cloud providers do not want to provide, of course. But they do have the required functionality to actually administrate your databases on a day-to-day level. And then they did patch Postgres to integrate with that. So what they provide is a web interface or a portal where you log in, or alternatively, they all have an SDK or a command line interface, and also Terraform integration is pretty good for all three of them. So what you can do there is you can create or delete, restart instances. You can change server parameters. They're called differently. They're called parameter groups or flags or whatever, but it's the same thing. You can look at the server logs in some form. I'll get to that in a minute. And they provide whitelisting of IP addresses. So that's a bit more generic than what Postgres does with these host-based access controls, PGHBA-conf, which you might know. So you can only whitelist a particular IP or a range, but nothing more specific. But that's already useful enough, I would say. There's replication and high availability of some sort for all of them. That's usually either a read replica with a manual failover, that's asynchronous, or it's a high available synchronous standby, but that's a cold standby that you cannot run queries on, which does automatic failover. And in general, you just have to pay double the price for, or another times the price for each standby, or whatever standby it is. So that can get quite expensive quite fast, but that's it, how it goes in the cloud, I guess. Right, so they also have automatic instant-wide backups, physical backups. So if you want to have logical dumps, you have to do them yourselves, but they provide that, and you can restore those backups when you spin up a new instance. If you don't want to have an empty instance, you can restore a backup, and that allows you to also clone an instance or do some disaster recovery, or to maybe recover to a certain point in time, and then copy out the data that's been deleted from the primary afterwards, and then copy it back to the primary. Right, and also what they're doing is they patch, they have maintenance windows, and then they patch Postgres, and I'll get into that later on in the talk about how good or bad they are at that. Right, so let's look at, well, those are the common things. Let's look a bit about more specifics. First up, Microsoft Azure Database. So that's actually two offerings. So that's single server and flexible server. And funnily enough, single server, that was before. So generally, Microsoft Azure is the newest offering of the three, and single server was the first offering, and that's Windows based. Maybe a general word on Postgres versions. So there's one major version per year. It's released in Q3 usually, and the development cycle goes from Q1 to Q1. So the current major version is 13, and the development cycle for the next major version, 14, which will come out in Q3 2021, has just finished. So that went from Q1 20 to Q1 2021. So Microsoft single server provides 9.6, 10, and 11. Postgres itself, the upstream project, has 5 years of support for releases, so it's currently supports 9.6, 10, 11, 12, and 13. Right, so you see that a single server has no 12 and 13 at this point, or maybe ever. There's read-only replicas with only manual failover. There's no automatic failover for a single server. But maybe a unique selling point for Azure is Azure Active Directory integration. So if your organization is invested in Azure Active Directory, if you have a lot of roles in there, and that might be a unique selling point for you, and you might want to look at that. Flexible server also has that. Flexible server is Linux-based, but it's also a preview, so maybe it's not production ready, though there has been, there's this release notes thing, there has been a release in late April, so maybe it's going to be generally available very soon, or even by the time the conference has started. It does support 11 and 12, and it does synchronous code standby, automatic failover by probably leveraging PG Auto Failover, which is an open source tool by Microsoft. So I guess they're using that. It also has Azure Active Directory integration. I already said that. And maybe one interesting feature is also has transparent PG Bouncer integration, which is a connection pooler. So that's making it quite easy to use that. And I don't think anybody else has that at that point. So that's also an interesting thing. Right, so next up is Google Cloud SQL. There's not a lot of unique selling points for that, except maybe, well, it's Google Cloud. If you use GCP, then it's quite handy to use that as well. It supports 9.6 to 13, so all major versions that are currently supported by Postgres. You can have both synchronous code standby, automatic failover, and read replicas. So flexible server does not have read replicas, so you have to choose there. Well, you cannot choose, but you can choose with Google Cloud. But other than that, it's I don't think there's any other super outstanding features there. It just basically provides what it provides. A bit the same for Amazon RDS. Amazon RDS is the earliest of them. It's pretty old by now. It also supports all the major versions. It has a proprietary multi-availability zone, high availability system. I'm not sure what that exactly is. I'm not sure what the Google thing is. And they also alternatively have read replicas. Right, that's so far. Let's have another look maybe at server logs. So server logs, you want to look, of course, have a look at what the server is doing, and if there's some problems, or maybe if there's some long-running queries and that kind of thing. So in general, they have these kind of query insight analytics things that they're trying to build for their platform. But for the raw logs, for a single server, you can download them on an hourly basis. I think up to 7 days in the past, so you can configure that. I'm not quite sure. Maybe it's 30 days. Not sure, but at least you can download them on the web interface. And you have something called Microsoft Log Analytics, where you can run queries on the logs, but you have to hook it up with that other service. So one problem, or I think one of the major problems with Azure Flexible Server right now, is that there is no direct server log access. That just doesn't exist right now. So maybe they're implementing it, waiting to have it implemented for going generally available with it. I'm not sure, but right now it doesn't have it. So the only thing, you're just stuck with Microsoft Log Analytics, which I think is not super adequate. So yeah, you might have to take that into account. Google Cloud Platform has also no direct server log, but you can have this Logs Explorer thing where you can search for instances and then stream or save the query results. So it's basically the same thing as a direct log access, I would say. And RDS allows for hourly log files again, but there you can also view or watch them. You cannot just only download them, you can also view or watch them, so that's nice. And you can also set up CloudWatch alarms. Right. The other thing I want to talk about is extensions, because Postgres is has a lot of extensibility. There's lots of extensions for all types of things in Postgres, and obviously with a cloud provider, you're stuck with the ones that they provide for you because you don't have Superuser-access. You cannot install or compile your own extensions. But luckily, this has improved a lot over the last years, I would say. So all of them provide a lot of the functionality these days. As you can see, like 40 to 70 extensions are provided. RDS is probably the one with the most. And there's a couple of them which are provided by all, which are, I would say, some standard core data types, and PostgreSQL foreign data wrapper for federation, and PostGIS for spatial, and PostGIS is an external extension, and PG-Audit is the other external extension for auditing. I'll get to that a bit later on. All the other ones are there. Well, those are the ones that are really provided by all, and then there's a couple which are provided by only some. So I made some notable extensions here in this table. You can have a look. As you can see, Azure Flexible Server is maybe not so great at those. I guess they're catching up here. They provide a few less, but in general, lots of you can see here whichever one you like and whether they're supported by it. Those are the ones that you can always create. Then there is also a set of extensions where you need to run where you need to load a library first, and those have to be set in the so-called shared preload libraries configuration parameter. And this is actually a different table here. So usually what you would do is you would have to you have a kind of like an enum multi-click thing where the cloud provider, you can just click whether you want to activate one or two. And as you can see, Google is very, I wouldn't say bad at it, but it doesn't provide a lot. So pg-stat statements is the core extension for query checking, and then that's basically activated everywhere. And then there's a weird trick to activate PG-Audit, which I'll get to in a minute, for Google. But otherwise, they do not provide access to shared preload libraries at all. All the other ones allow for some of those extensions. So you can have a look here which ones are provided by which cloud provider. Right, so I just said that Google Cloud Platform has a weird way to do PG-Audit activation. Actually, you cannot do it via the user interface, but there's a CLI trick. We had G-Cloud CLI, you can actually activate it. And what does auditing do? It allows you to configure auditing, and then once there's an audit event, this will be emitted to the Postgres log, and then from there you can run a watcher or alert on it and act on it. There's basically two ways to do it. You can do session-based auditing with an audit role to maybe auditor, and when you grant delete privileges to this auditor role on a table, then every time somebody runs a delete statement on the table, there will be an audit event in the log, and this way you can audit deletes on that table. That's very handy. But there's also role-based auditing, where you can say every time user X deletes something anywhere, because they shouldn't do it, then it's an audit event as well. And there's the problem. There's the problem that this is only working on Google Cloud and Amazon. Azure does not allow this. This is because this auto role set thing requires super user privileges, and Google and Amazon apparently have patched the server there, and Azure has not so far, so you cannot do that. And then it makes actually auditing or generally logging as well pretty difficult on a per log basis. So if you have some roles which produce a lot of log entries, and you just want to have some type of log only for some rows that are used very sparingly, but you want to know when they're used, and that's very difficult to do with Azure, or maybe not at all. You have to filter it after the fact. Right. That's it for the functionality, I guess. So let's move on to the community involvement. So Microsoft acquired Citus in 2019. They got a couple of good developers out of it, and the Citus Hyperscale product. Dimitri Fontaine is a contributor. So contributor in this case means somebody who is actively recognized as a contributor to Postgres. However, they hired 4 major contributors about a year ago, and in March 2020. That's Andres Freund, who's also on the core team since, Jeff Davis, Thomas Munro, and David Rowley. And they are very, very senior Postgres hackers, and they did a lot of work in the Postgres 14 development cycle since then. So Microsoft is actually by far the biggest contributor at this point to PostgreSQL development when it comes to these 3 at least. Google, on the contrary, does not a lot of contributions or development work. They do provide some bug fixing or bug reports now and then, but I only found Hanu Krosing and Paul Martinez with a google.com address. It's of course pretty difficult to figure out the company affiliation from all of the contributors, but I tried. So if you know of somebody who's working for Google and who's been doing work in the last year, you just let me know in the chat. So those 2 are the only ones I could identify. Google also did not acquire any kind of PostgreSQL company to help them with their cloud offering. Amazon, on the contrary, did acquire OpenSCG in 2018. So there's quite a lot of senior Postgres people with it. Jan Week, who was on the core team and who also left Amazon now just this month for Crunchy Data, was there, and Jim Nasby and Jim Lodansky and some others. And apart from Jan Week, mostly Nathan Bossert is a contributor and provided patches. So most of the patches that Amazon provided are through Nathan actually, and Bertrand Drugo. So what I did to quantify the community involvement is I checked all of these people that I identified to work for Microsoft, Google, or Amazon, and I looked how many emails they sent to the central GSQL hackers development list during the 14 development cycle, so over the last year, and also how many commits they authored during that cycle. So if you look at that diagram, you have to note that the y-axis is logarithmic. So actually, Microsoft did a lot of work there, sometimes 10 times, basically 10 times as much as the others, or 10 times as much as Amazon, which again did 10 times as much as Google when it comes to community involvement over the hackers list, but also for commits during the V14 cycle. Of course, with commits, it's always also very difficult to figure out. For example, Andres Freund did a lot of scalability work, which will affect performance quite heavily, but there was only 1 commit maybe. But overall, they had about 30-40 commits, Microsoft, and Google only had 2 commits. So you can see that Microsoft really did a lot of the contributions there. Right. That's as much as I can say about the community involvement. So the next point would be major minor versions up-to-dateness. What I mean with that is, how good are they with introducing new major versions after they got released by Postgres? And how quick are they with patching their cloud offerings after PostgreSQL issues a patch release. So Postgres does it does quarterly patch releases on a very clear schedule. So it's very clear when they arrive. And I did some. I checked the numbers when all of the all of the three providers, all the four offerings were generally available for a major version, and looked at how long the delay was since the actual upstream release. So that's in days there. As you can see, that's sometimes several years. Sometimes it's only days. So Amazon RDS, I would say, is the most consistent here with maybe 150 days, which is something I think is a useful thing. So Postgres, as I said, releases in Q3. And you would usually wait a couple of months or 1, 2, or 3 patch releases until it stabilizes. So actually coming up 150 to 200 days later is a useful thing. Google, for example, released 13 with a 13.0, I believe, which I find interesting. So Google goes from way up to down, and Amazon is pretty consistent. Now with Microsoft, that's interesting in the sense that single server got released, but then they stopped doing new versions apparently, because 12 and 13 have not been released for single server, whereas flexible server got released with 11 and 12 basically at the same time. So that's basically they were both released about in late 2020, so 1 year after 12 got out and 2 years after 11 got out. So we'll see how that goes. They have not released 13 yet, but probably that will happen in due short. Right, so about the patch releases, and there it's getting even more worrying for Amazon, because Azure Single Server, which is their only actual production-ready offering right now, because Flexible Server is still in preview, they stopped doing patch releases about a year ago. So the last one came out in May, and that was the Q4 2019. That was already delayed by 220 days patch release, and they haven't issued a patch release since. Now, Google Cloud also took a long time for patching, as you can see, or maybe they skipped one. But I couldn't find any data from before 2020, so 2018, 2019, I didn't find any Google Cloud patching data, so I cannot say whether anything happened there. I tried to contact them, but they did not reply. Again, the most consistent is Amazon RDS. They do skip 1 or 2 once in a while, but in general, they will patch it in around 50 to 60 days. Right, so as a conclusion for that, Amazon RDS is the most consistent. Information for Google is not available, and Azure Single Server seems to be abandonware, with Flexible Server taking over. Now, I did actually ask the Azure people about that on Twitter, and I got into a conversation, and one of the developers replied that they're actually, they plan to do it in the next 2 or 3 months. That was in early February, so it should happen, we'll see. But they also claim that they periodically backport critical bug security fixes. And that's something that we have to take on face value. I find it weird because in general it should be easier to just patch it, and I'm not aware of any showstopper in those point releases that would need re-architecturing. Well, but that's just for your information, so maybe it's actually it's still there, but it's certainly worrying that single server has not seen a patch release for over a year. And it's actually 5 or 6 releases behind now. Right, so the final point for the last couple of minutes would be the out-of-memory behavior. This is, again, pretty specific, but we saw it with some clients we worked together, and it's pretty difficult to get right, especially in a cloud context. So what's the problem? Well, the problem is that PostgreSQL in general should be, the system should be configured so that PostgreSQL does not get killed by the out-of-memory killer, because if that happens, if one of the Postgres processes, and Postgres is process-based, gets killed by the out-of-memory killer, then Postgres assumes that all the shared memory is corrupted, and it has to abort all the running, it kills all the other running connections and does a crash recovery. So that's a small to possibly longer downtime. and that's something that should be avoided. So usually how you avoid this on an on-metal server or in the VM is you would disable memory overcommit, so that you get out of memory errors if there's any memory pressure. And then just the query that caused that out of memory condition is being cancelled, but the server does not have to do a restart. But the problem is that if C groups or containers are used by the cloud provider, then proper out of memory behavior is pretty difficult to achieve, because C groups makes it very difficult to not run into the out of memory killer when there is memory pressure, and also there could be bad neighbor behavior where other C groups on the system take a lot of memory, and then the kernel decides to kill Postgres because for some reason it thinks this one is just the last to ask for memory and it should be killed. So this is very difficult to get right. So we did some tests here with the small instances for on all 4 offerings, trying to get a small instance and then setting the work memory setting very high, or as high as possible, and then running a query that easily eats up a lot of memory and see how they react. Now, for Microsoft Azure, it was the same for single server and flexible server, which is maybe a bit surprising because they're totally different implementations, one Windows, one Linux. But for both of them, as far as we could tell, at least on the instances that we tried, and again, we only tried for small instances. We did not try all of the different instances, or we did not try all of the different regions maybe. But for the ones we tried, we got out of memory errors. So we did this query, and at some point it failed with an out of memory error, and the query got cancelled, and that was it, and you could run the next query. And nothing happened, so it was continuing. This is how it should be. So Azure is apparently well configured in that sense, or we were just lucky. Now with Google, we actually saw the problem with a client on Google Cloud, so we were not surprised that we also saw it here. Here it happened that the server, one of the server processes was killed with signal 9, which means the out of memory killer ended it, and now Postgres had to terminate any other active server processes and go into recovery mode. So that's exactly what you don't want to have to do. That's the problematic behavior. But we also saw this on Amazon RDS. So again, for this type of thing, this only happened on one instance type. We did not do a very large study, but here again, after this query, the system was going into recovery. At least the connection was still the connection could be reset. So that was at least possible. Maybe the crash recovery was very quick, but in general, that's also a problematic behavior. Right, so to summarize here, Azure was doing okay, and Google and RDS were not doing okay. Right, and that actually already ends my talk. Thanks a lot for your attention. If you have any questions, I hope I can answer them in the chat. And here are some links and contact information. And I hope you enjoy Percona Live Online, and I wish you a nice conference. Thanks.